In this video, we're going to graph quadratic functions in vertex form. So obviously, vertex form is where we're able to quickly find the vertex. So there's two major forms for the quadratic. This first one is called the standard form. Obviously, a cannot be 0, otherwise it would no longer be a quadratic. But in this one, we don't have anything grouped or factored. We just have all of our terms from greatest degree to least degree. So we're going to talk about that one in a little bit. We're going to start, though, with the vertex form. And this is the vertex form of our equation. And the great thing about this is that we can easily find the vertex just by looking at the h and k values. Just as we talked about before in transformations, this is always going to make it the opposite sign of what we see. The axis of symmetry is the line x equals h, and the axis of symmetry is the line at which I could draw and fold that parabola exactly in half. And then if a is greater than 1, so if it's positive, then our parabola is going to open up like my first example. But if a is less than 0, which means it's negative, then our parabola is going to open downward. So we are going to graph this first question together, and really what we're doing when we're graphing is we're looking for landmarks or major points or things that we can graph. We don't need to necessarily graph the entire thing in 18 points or whatever. All we're trying to look for is what's the basic shape of the graph. So the first thing I'm going to do is I'm going to find the vertex and the axis of symmetry, and that has everything to do with these values. So the vertex and the axis of symmetry, the vertex is found by taking the h value, which remember is the opposite sign, so positive 2, and the k value, which is negative 9. And that point to negative 9 I can go ahead and graph. Then I can look at the axis of symmetry. The axis of symmetry always has to do, again, with h. So my vertex is 2, negative 9. My axis of symmetry is a line, and so you need x equals, and then it's whatever that x value is. And if I were to graph that line, it would simply look like this, which is a dotted line at x equals 2. And the reason we graph that is that if I have something on the left side of that line, I can reflect it to the right side or vice versa. One thing I didn't mention, but I'm going to find anyway, is the direction of opening, because obviously I want to know, is this pointing up or down? And that has everything to do with the a value, and in this case there is no a value, and so the a value is 1. Since my a value is greater than 0 or positive, my parabola will open up. So far I have a basic idea of what my graph is going to look like, and now I'm going to find my intercepts. So let's start with my x-intercept. Typically there's 1 or 2. Since I know my parabola is down here, opens up from the bottom, I know there's going to be 2. So I'm going to set y equal to 0, because that's what we do for an x-intercept, just as we have before. X minus 2 squared minus 9, and I'm going to solve this. Easiest way to solve this is add 9 to each side, and then take the square root of each side. And when I do, I get plus or minus 3 equals x minus 2, because on this side the square root and the squared cancel. So I get x minus 2 equals 3, or x equals 5. And then I get x minus 2 equals negative 3, or x equals negative 1. So I can plot those points as well. X is 5, x is negative 1. And then I also want to go ahead and find the y-intercept, and the y-intercept is found by setting x equal to 0. So y equals 0 minus 2 squared minus 9, which is 0 minus 2 is negative 2 squared minus 9, which is positive 4 minus 9, which is negative 5. So on y, it goes through at negative 5. Now, I already have 4 points. I really want a minimum of 5. Then I'm just going to use that axis of symmetry that says if I have a point that's 2 to the left of my axis of symmetry, I also have a point 2 to the right. So if I wanted to, I could certainly plug in some other random value like 8 and find out what my y value is. But at this point, I feel pretty good about my parabola. Oh, not about my drawing abilities, but about my parabola. It's going to look something like this. And really, when you're doing this, you're going to be probably matching, so it'll be easy to find those landmarks and then match your graph. We'll do one more together before I have you do one on your own. Again, I didn't mention direction of opening, but we'll want that as well. Notice on this one, I have a negative in front. That means A is -1, which means this parabola will open down. So now let's find the vertex and axis of symmetry. The vertex would be the opposite of +2, which is -2, and -1. So -2, -1 is my first point. My axis of symmetry is an equation of the line x equals -2. Don't forget the x equals. A lot of people do that. So then I'm just going to write that or draw that dotted line in. And now I have to find some other points that are on my line. So I'm going to start with the x and y-intercepts, and if I need other points, I'll go from there. So again, let's start with the x-intercept. The x-intercept is setting y equal to 0. And if I find the x-intercept, notice I'm going to add 1 to each side. So I have 1 equals negative x plus 2 quantity squared. I want to get rid of that negative, so let's take each side divided by -1. And now I have where something squared is equal to a negative value. Is that possible? Can I take 2 positives and multiply them and get a negative, or 2 negatives and multiply them and get a negative? No, I can't. So there's no x-intercept. Now again, how would I know that in addition to the math that I just did? Well, we already found that here is my vertex, and we already know that it's open down. So I'm not going to know exactly what my graph looks like, but I know it's going to kind of go like this, and we'll make that a little bit more precise in a second. But we know then that it wouldn't cross the x-axis. For the y-intercept, I'm going to say y equals -0 plus 2 quantity squared minus 1. Remember the negative's on the outside, so this is just 2 squared minus 1, which is negative, and then 2 squared is 4 minus 1. So really I have -4 minus 1, which is -5. So at -5, I know that my line, my parabola, crosses the y-axis. Now I'm going to use my axis of symmetry to go ahead and pop this over to the other side. So notice this was 2 away. I went 2 away to the other side. Now this one I only have 3 points, so I might actually want to have 5 points. That's pretty typical. So I'm just going to choose 2. I'm going to choose an x value of 2. So I'm going to say y equals -2 plus 2 squared minus 1, which is negative, that's 4 squared minus 1. And it looks like I went too far, because this baby is going to be -16 minus 1, or -17, and that's way off my graph. Probably should have chosen 1. That would have given me 3 squared, which is 9. -9 minus 1 is -10. Sorry, I didn't show you the work on that one. I don't want this to be a 30-minute video. So if I do plug in -1 or +1, I end up down here at -10, and then I'm going to use my axis of symmetry to pop another point over here, and then again, now I'm going to just draw in my parabola. Here's one for you to try, so go ahead and try this question, then press play to see how you did. Again, I'm going to follow the same steps. I'm going to find my vertex, my axis of symmetry, which I don't have to do any work for. The vertex would be -2, -4. An axis of symmetry is always the same x value. X equals -2. So -2, -4, and x equals -2. This baby's opening up because there's a positive one here. So up, meaning I should end up with some x-intercepts this time. So let's find the x and y-intercepts. The x-intercept is me plugging in a 0 for y. X plus 2 quantity squared minus 4. Add 4 to each side. Oh, that was fun. I switched colors without knowing it. Take the square root of each side. Square root of 4 is plus or minus 2. So again, that means x plus 2 is positive 2, or x is 0. And then x plus 2 is negative 2, or x is -4. So 1 at 0, 1 at -4. I feel pretty good about this. Now, do I really have to find my y-intercept? Well, probably if I'm doing an assessment, I should show the work. But the work would be that y equals x plus 0. I'm sorry, that's wrong. Woo! 0 plus 2 squared minus 4. 0 plus 2 is 2. 2 squared is 4. 4 minus 4 is 0. Now, why did I say I didn't really have to do that? Well, I already graphed the point 0, 0, so I already know it crosses at 0. Again, I might want to find another point on my line here, so I might plug in 2. Let's just do the mental math. If I plugged in a 2 here, 2 plus 2 is 4. 4 squared is 16. 16 minus 4 is 12. So 2 comma 12. Again, I overshot. It's a little bit off my graph, but you get the idea. Then I could go the same thing in the other direction. So 1, 2, 3, 4 off of the off of the axis of symmetry, and end up with something like this.